All right, folks, it's Bass Action, back in action here. In this video, we are going to start to look at how to solve triangles, and that means find all the missing parts, how to solve triangles when the triangle is not a right triangle or some other type of special triangle. What we're going to do is we're going to learn this new thing called law of sines, and you don't have to really memorize the different patterns. It's going to be really obvious which patterns are going to work and which are not, but just so you know that the law of sines is going to work with these types of patterns. Now, they're not triangle proofs, they're the patterns in terms of the information that's been given. Now, this one right here, this side-side angle, you'll recall from your geometry days, is not a triangle proof method. And we are going to save this one, and we're going to do it on a separate day because it is a very special case. Now, I want to take a look at this triangle here, and I want to give you a little bit of information how these are going to be marked. So when you're given the capital letters in any triangle will represent the vertices, and then what we can do is we can mark the sides across from those angles with lowercase letters to help us keep track. So the side across from angle B is going to be marked with a lowercase b, across from angle E will be marked with a lowercase e, and across from angle C in this case would be a lowercase c. Now, don't worry that these are difficult to tell apart, the capital versus the lowercase, because when the information is given, angles will always be labeled with the degrees and the sides will not. Now, here's what law of sines tells us, and we'll look at the proof quickly in a moment. What law of sines tells us is that within a single triangle, it doesn't move between separate triangles, but within a single triangle, the relationship between a side length and the sine of the angle across from it will remain consistent throughout the triangle. So for example, here's our formula. E divided by the sine of angle E is the same as C divided by the sine of angle C, and B divided by the sine of angle B. So that is going to remain consistent throughout the triangle, and that's going to allow us to find different parts. I will also note that sometimes you will see these proportions, these ratios, written the opposite way. Some books write the sine of the angle in the numerator, and they put the side in the bottom. Don't be bothered. All that matters is that you remain consistent when you write those ratios. Now, let's take a look at real quick on why this actually works. In this case, it's kind of helpful for us to actually look at where we're trying to go. We want to prove that E divided by the sine of E is equal to B divided by the sine of B. Now, if this proportion were true, we should be able to cross multiply this and get a true statement. So we should be able to find out that B times the sine of E is equal to E times the sine of angle B. So if this is true, then we should be able to see that this is also true. So now, let's take a look at this picture. I've marked a bunch of measurements for us to make the process a little quicker. And our first step in our little proof is to look at angle E. So we're going to focus on this little right triangle because, of course, we know how to work with right triangles. So if we are asked to solve for x using angle E, we're going to say x is our opposite, B is the hypotenuse in that little triangle. So we can say that the sine of angle E is equal to x over b. And of course, we know from our geometry review that we can put this left side over 1, and then we can say that x, so this means that x is going to equal b times the sine of e. Now, we're going to repeat this process looking at the triangle here on our right. So we're going to look at this triangle right here. And again, it's a nice right triangle. This time we're going to look at angle B, and we're going to still solve for x, noticing that x is, of course, the same to each of these triangles. So now we're going to have our opposite and our hypotenuse again. So we're going to say the sine of B is equal to x over E. Once again, we can put this left side over 1, and that's going to tell us that x is equal to E times the sine of B. Now, of course, we were trying to find that these two were equal, and in fact, we can see then that they have to be equal because when we look up here, we have our same exact expressions, and they both equal x. Well, if they both equal x, they equal each other, and we have therefore proven exactly what we wanted to prove. Now, we could repeat the process using different heights of the triangle, but I'm going to leave it with just this one. If you want to see the other perspectives, feel free to ask me for that in class. Now, the next thing that we're going to do is we're going to look at how to solve a triangle. And again, solving a triangle means finding all the missing parts. That's what this direction means, find any missing measures in the triangle. There's a temptation, I want to give you a heads up, there's a temptation to turn this value right here to a decimal. This, of course, would be a repeating decimal, so you do not want to convert this one to a decimal. If you can get a nice terminating decimal, fine. This one does not, so we're going to immediately rewrite this as 17/3, okay? We do not want to convert that to a decimal. Now, we're going to draw a quick sketch of a triangle. It is not going to look to scale in any way, shape, or form. I'm going to label this ABC. It doesn't matter the order. I just always start from the left, and I just go around clockwise. That's just the way I like to do it. So, my angle B is 25 degrees. My angle C is 110 degrees. Obviously, this picture doesn't make any sense, but that's okay. And our side A is 17/3. Again, we are not writing that as a decimal. So we're going to cross from angle A, and we're going to write 17/3. Now, the first thing that we need to be able to recognize in this picture is that we can actually find the measure of angle A without doing anything significant, because all three angles add to 180 degrees. So we can quickly find the measure of angle A by doing 180 minus 25 minus 110, and that's going to get us a nice 45 degrees. So I can put it here, and I can even put it over here on my answer blanks. Now, we need to be able to solve this triangle. Since it's not a right triangle, it's not an equilateral triangle, what we want to do is recognize that we can use the law of sines, because in this problem, I have what I like to call a link. Okay, that's kind of my own little phrase. I call it a link. And a link happens when you know the measure of an angle and the measure of the side across from it. So we have a link right here. We know 45 degrees, we know the side across. There is our link. That link is going to allow us to find everything that we want to find in this triangle. So I'm going to set up that proportion. I'm also going to go ahead and I'm going to label this as side C, and I'm going to label this as side B. So of course I know that B divided by the sine of angle B, oops, let me fix that here, B, I got ahead of myself, B divided by the sine of angle B, which is 25, is going to equal 17/3 divided by the sine of 45. And again, we're just going to write this as a 17/3 and the sine of 45. And of course, that also equals C divided by the sine of 110. So I can continue. And notice I'm writing all three proportions, and that's totally fine. All three ratios I meant to say there. And the sine of 110. Okay, now what we can do is we can start to kind of break this down into little proportions, ignoring ignoring one of the ratios. So for example, if I take these two right here, kind of ignoring this one over here, if I were to solve this, I would cross multiply, and I would get B times the sine of 45 equals 17/3 times the sine of 25. I then could divide both sides by the sine of 45. These would cancel, and I could just type this into my calculator. So with your calculators there at home, you should practice typing this in, because that can be the hard part sometimes. So our B is 3.39. We're going to take this to the hundreds. We can also, if we want, put it into our picture, 3.39, and I'm going to write it over here on my answer blank as well. From there, the next thing I can do is continue to solve for C. And now I'm going to look at these two pieces, and I'm going to cross multiply here. Now I'm ignoring this B. Notice I'm not using this value to continue solving, because this one is precise and this one is going to be an approximation. So now I'm going to cross multiply. I'm going to get C times the sine of 45 and 17/3 times the sine of 110. Again, I'm going to divide by the sine of 45. And these are going to cancel. And if we type this right-hand side into our calculator, and if you struggle with the calculator part, we'll just talk in class. It's okay. And then we're going to get a C value of 7.53. Again, rounding to hundredths. I'm going to put this back in my picture very quickly because I want to point one last thing out. The last thing that we need to remember from our geometry days is what I call big side, big angle. So we've got big side, big angle. And that means that our triangle should make sense. The biggest measurement should be across from the biggest angle. The smallest measurement should be across from the smallest angle. You should also be able to take these measures and use your converse Pythagorean theorem and actually show that the triangle was in fact an obtuse triangle. So there's lots of ways for you to also be able to check your work on these problems. Okay, in the next video, we're going to look at some triangle area, and then on another day, we're going to look at the side-side angle pattern.